HCl and H2O. What are intermolecular forces that are happening in there? Because I want you guys to understand something before I even ask this question. There is a difference between interaction. There's what we call covalent bonds or covalent interaction, which means those we call them intra. I don't know if you understand. It's happening inside the molecule. But intermolecular forces is all about if this pen comes close to this pen, what's going to happen? Is that okay? What's going to happen if these two pens come together? What happens when you have got a north and south of a magnet? They do this, right? Think about that as an intermolecular force. Is that okay? It's like what happens if a molecule attracts the other one or approaches the other one. Is that okay? Are you with me? Yes. So you need to really check if a molecule is polar or non-polar before you can even decide. What is polarity? It's a molecule that has a what? A net dipole moment or dipole interaction. That means there is a difference in electronegativity. Is that okay? So if you look into HCl here, this is partially positive, this is partially what? Negative. So there's a difference in electronegativity here, and then we say this molecule is polar, yes or no? It is polar because there's a difference in electronegativity. Which side does the dipole moment goes to? It goes to the one that is most electronegative. Do you understand? So the direction of the net dipole moment here is this one. Do you guys understand that? Yes. Do you guys know what is electronegativity? Let me start from there again. What is electronegativity? It's a power of an atom to withdraw electrons towards itself when it's in form of a compound. Do you guys understand that? When we do Lewis structures, why do we choose the least electronegative atom as a central atom? You see, these things they do link. Why do we choose the least one? Why do we not choose the more electronegative atom as a central atom? Think about it. Think about the definition. The definition says, I want to withdraw electrons towards myself. That means I'm what? I'm more electronegative. That means I'm not willing to share. Is that okay? But if I choose the least electronegative one, it is willing to share. Hence we make it a what? A central atom. So a central atom is always the least electronegative. The one that is what? More electronegative is a terminal atom. Are we good now? So always choose the least electronegative atom as a central atom. The more electronegative one is what? A terminal atom. Because the central atom is willing to share. It says you get an electron, you get an electron, you get an electron. Everyone gets an electron. Is that okay? Because it's willing to share, it is least electronegative. Right? Let me give you an example so that you guys can make sense about this. So we say this molecule is polar. So if it's polar, it has a dipole. Is this a molecule polar, yes or no? Is this polar? Why? Because oxygen is more electronegative than what? Hydrogen. So if you draw this, you will draw it as water looking like this. And then you'll have H here, you'll have H there. Is that okay? And then the net dipole moment goes through, and that is more electro. This one, it will go this way. Because oxygen is more electronegative than what? Than hydrogen. You need to just learn these things. So we say this one also has a dipole. This one also is dipole. So we say here this is dipole, dipole because there are two polar molecules. That means dipole, dipole happens when there are two polar. What about when there are two non-polar? It's London forces, right? London dispersion forces, or we can say induced dipole, induced dipole. That means these two things don't have a net dipole existing in them. Is that okay? So the induced dipole, induced dipole. The induced dipole simply means that at a random motion, one of it can have the electron cloud shifting and inducing a dipole to the next one. So we saw it as a London dispersion forces. Okay. So please guys, make sure you understand that. The one thing that I wanted to speak about again is this one that is called what? Hydrogen interaction. You just say interaction. Because this is an interaction between molecules. Or hydrogen forces, you can also say that. So what is happening in hydrogen forces? Let me just ask, because you guys said you are good at this, and I want to make sure that if you get a question like this, you do not fail it. What happens when it comes to hydrogen forces? Teach me something that I don't know. Yes, sir?
Hydrogen interacts with nitrogen, oxygen, chlorine.
Yes.
There's a very high electronegativity.
So this is when, you did it very, very well, okay? This is when a hydrogen interacts with either nitrogen or oxygen or fluorine of the other molecule. Is that okay? For example, let me ask you something very nice. So do you see water, right? Do you see water? Water looks like H2O. And then how about a molecule that has NF3? Let's talk about that. Is this molecule polar or non-polar? Is this molecule polar or non-polar? NF3, is it polar or non-polar? Is it polar or non-polar? I'm not getting the answer that I'm looking for. Okay, let's go back. Rewind. What will happen if you have CH4? Is that molecule polar or non-polar? The minute I'm not getting the same answer, I'm going to ask it again. Is this molecule polar or non-polar? Why are you saying it's non-polar? Because of the shape, yes? So if you draw this molecule, guys, this molecule is non-polar, okay? It is what? Non-polar. How do we know that? If you draw the Lewis structure, it will look like this, yes or no? You put H, you put H, you put H, you put H there. So once two molecules that are similar are facing one another like this, they cancel, yes or no? Yes. So this H cancels this one, yes or no? Yes. This H cancels this one, so this molecule is non. Are we together on this? But how about a molecule that looks like CH3OH? Do you guys want to attend to this one? I'm going to come to you now. If you have got CH3OH, what happens in there? You will draw the C. I think I'm using a pen that you guys can't see. Can you guys see that? I'm going to use something bigger than that. Shh. So, I was talking about CH3. I'm going to come back to my two structures there. Shh. I said CH3OH looks like this. Remember that? This is my CH3OH. The central atom is C there, and then you've got OH this side, and then you've got H, then you've got H, then you've got H. Which molecules cancel one another? The one that looks there? Same. So this guy, because it's facing this one, it will cancel. But do you think these two things cancel? No. So this molecule is what? Polar. So this molecule is polar. Can I give you one last thing that you can use to cram to tell people if stuff is polar? Once they are lone pairs, you see the lone pairs that you can see there? Once they are lone pairs, it's a polar molecule. Because in chemistry, the lone pairs are the one that starts the reaction. So it will be able to attract other molecules and react further. So once the lone pairs already in your mind, this is some polar thing, okay? So there is a difference in electronegativity here, and oxygen is the one that is more electronegative. So the net dipole goes towards that oxygen. Okay, so I was on NF3 and H2O. I wanted to show you that sometimes in intermolecular forces, you can have more than one interaction happening. Is that okay? That's what I wanted to explain there. So if you look into the structure, if you have NF3 and H2O, what sort of interaction do you guys get there? Draw the Lewis structure of the both atoms, is that okay? Molecules rather. So all you will have there, you will have N. I hope you guys do understand when I draw lines like this, what does this really mean? Do you guys see that? And this molecule will look like this. Do you guys see that even if you forgot that these two F's will cancel, for the fact that there's a lone pair, it makes this molecule what? Did I just make your life easy? Yes. Please, guys. And then now, You see oxygen is like this. And then there are two lone pairs there. But these two things, since they're not facing the same, they are not facing one another, they are not going to cancel. So these molecules are both polar. So we say what? This one is dipole, dipole, yes or no? And also there's hydrogen happening in here. Do you guys see that there's also hydrogen forces? Between this hydrogen and this fluorine, because the hydrogen has to interact with either oxygen or fluorine or nitrogen, yes or no? Yes. So that's one of them. Also, this hydrogen is interacting with this one. Do you see that? Is that okay? So these are hydrogen interaction. There could be more than one. That's the point that I'm trying to raise here. So if you cannot decide if a structure is polar or non-polar, draw the Lewis structures. Already we know that this will cancel that, but look at what we are remaining with. Do you guys see that? We are remaining with a polar structure. I do not know if you guys do ion dipole. Do you guys do that intermolecular force? Ion dipole is self-explanatory. It's an ion that interacts with the what? A molecule that is what? Polar. Once we say dipole, it's a polar molecule. But once we say induced dipole, that is a London force. That means this one did not possess a polarity. That means we induced it. Is that okay? Am I with you guys? 100%. Alright, and then when it comes to organic chemistry now, you need to really learn a few things. There is something that we call saturated and unsaturated. Do you guys understand that? Yes. Saturated means what? No double bond, yes or no? Those are your alkanes. Alkenes are unsaturated. Think about it like this. Do you understand why people always say you must always resort on eating plant healthy fats over animal fats? Do you guys know why? Huh? Always eat nuts over what? Animal fat. Why do they say that? Because the other one is saturated. The animal fat is solid at room temperature. It is saturated. And the plant cell is unsaturated. It means it has got what? Double bonds. Do you guys see that? And the one that is saturated is solid. The other one that is unsaturated is liquid. The one that is found in avocados. Do you guys know that avocado has some unsaturated fatty acids in there? That we think or that we know that they are very healthy? Yes or no? Macadamia nuts. Those are what? Unsaturated fatty acids. But the one that you get on that pork, you see that strip of pork? That is saturated fatty acid. Do you guys understand? Please need to know those. And then you need to know your carbonyl groups. That is what we call a carboxylic acid. Tell me more. Aldehyde, yes or no? A ketone, yes or no? What is the difference? An aldehyde looks like a CHO at the very end. You guys understand that? Yes. And then a carboxylic acid, I don't know if they will allow me, you guys are going to allow me to write it like this. Can you? Do you understand that means carboxylic acid? Or you can write a carboxylic acid looking like this. All I'm trying to say is carboxylic acids, aldehydes, are at the very end of the structure, yes or no? They are not in between carbons. But ketones are found in between two carbons. Do you guys understand that? So that means if you're looking at a ketone, you say it's a carbon that is attached to another carbon and to another carbon. That is a ketone. Because an aldehyde, this beautiful structure that I drew here, looks exactly like that. Do you see that on the right hand side, there is no carbon? Are you guys with me? That makes it what? An aldehyde. Cool bananas? What is a primary alcohol? What is a secondary alcohol? What is a tertiary alcohol? What is a primary alcohol, guys? You haven't done it? No, I know you've done it. You guys haven't done it this side. You have. It's just that you probably. It's a slight information that is extremely important that you probably forgot. Okay? Yes, ma'am. You were raising up your hand. You're saying?
Sir, I could be wrong. I think I'm wrong. But
You can't be wrong, I know. Yes?
Primary alcohol, sir, isn't it when it's connected to one carbon, like it's on the side of it, like secondary? There you go.
The definition is lethargic. Yes, ma'am?
Isn't it when the hydroxyl group is connected to a carbon that is connected to only one other carbon?
That is the right definition. It's about the neighbor of the carbon that contains the hydroxyl group. Do you guys understand that? For example, if you look at it like this, if you have a thing that looks like there's a carbon here, okay, let me just say HHH, and then there's an OH. Do you see that this is a primary alcohol? Now let me draw as many alcohols as possible. By saying alcohols, I don't mean the ones that you guys know. So I'm looking at this. So what will happen if now I put an OH there? Is that okay? I put this one now. I put another one, CH3 here. I think you guys know that this will be CH3. Is that okay? I'm trying to come up with a fancy one here. CH3 again. And then this is what? So let's talk about these three different types of alcohols that I just wrote for you. So this is alcohol number 1, alcohol number 2, alcohol number 3. Let's talk about this one. Do you guys see that these alcohols are all different, yes or no?
Yes.
So this we can say it's a tertiary alcohol because it's an alcohol that is attached to a carbon that has 3 neighboring carbons. Do you guys see that? That is 3rd degree. You can say that. Is that okay? So this is tertiary alcohol. A secondary alcohol is a carbon that is an alcohol that is attached to a carbon that has got 2 neighboring carbons. This one is a secondary alcohol because this carbon right here has a neighbor this side, has a neighbor this side. So we say secondary. This one is primary because it is attached to a carbon, the carbon itself. If I put H here, I put H here, it makes this carbon having 1 neighbor, so that is a primary alcohol. Please, you need to know that. It's very important. Just like an alkyl halide, the primary alkyl halide, it's just about the neighbor of what? The carbon that contains that halogen group or that OH. Is that okay? Are we together? Do you guys want to teach me something about the IUPAC system? What is the IUPAC? What does it mean? It's about naming of structures. Do you guys understand that? What is the first thing that you need to do when you're doing the IUPAC system or the IUPAC rules? Determine the what? The longest. Determine the longest carbon chain. Once you determine the longest carbon chain, you are then going to be able to see, oh, this is my longest. Please don't forget that we start from math, ethane, propane, butane. What is number 5? What is number 5? 6 is what? 7 is hep. 8 is oak. 9 is what? Let me slow now. 9 is what? No name. Is that okay? 10 is decane. Let me repeat it. Number 1 is what? If there's 1 carbon, you say it's what? Meth. So if now, let's say you have the long group and then there's a branch of 1 carbon, you say that is methane or methyl group. Do you guys understand that? If there are 2 carbons, you say it's an ethyl, if it's an alkane. Is that okay? 3 propyl, 4 butyl, 5 pentabon or pentane. Do you guys see that? 5 member ring. 6 is hexa, 7 is hepta, octa, nonane. 9. Nonane, right?
Yes.
Okay. Nonane is like nonane. Nonane. If it's 9 carbons and it's an alkane, is that okay? That means this is a long, unsaturated, saturated 9 carbons. Do you guys understand that? Are you with me? And I feel like the first way I can explain the other things is when we do questions. Are you guys following through? So let's start with question number 1 of the reactions, which is page number 69. Do I have it in here? Okay, let's get started. This one, page 19, sorry, my bad. Give reason why alkanes are saturated carbons. Didn't I say because they possess no double bond? You see that you already have a mark and you haven't started thinking. Yes or no? Why are we saying alkanes are what? Saturated. Alkanes are saturated hydrocarbons because they do not have double bonds. They only contain single bonds. You can even say they don't have, let me write it because I feel like at this point I need to spoon feed you guys. Because organic chemistry, guys, is a baby, it's a piece of cake, okay, so you guys have to do it. Alright, so I'm saying they contain 1.1, they contain a single what? Bond. You can say that as one, because it's one mark there. Or you can also say they do not have double what? Bonds. And then the last one you can also say they don't have triple bonds. Is that okay? If I may ask you guys, what are triple bonds? Triple bonds are alkynes. Do you guys remember that? Please remember that. They are called alkynes. Triple bonds. Means they are sharing of 3 electrons in one, 3 on the other one. Is that okay? So that it looks very big. Is that okay? We call them bulky molecules. So please be able to do that. Now let's look into question number 2. Write down a structural formula of a functional group of alcohols. They say write down a formula of a functional group of alcohols. They don't even say primary, secondary, or tertiary, right? Yes or no? Yes. So I think you can draw anyone that you like. Is that okay? As long as there's an OH. They didn't restrict you. A functional group is just an OH, yes or no? They're looking for the functional group there. As I was saying, you can simply come and say COH. Is that okay? You can have H here, you can have H here, H there. They're looking for the functional group. This makes this one a primary alcohol. They didn't say secondary alcohol. Is that okay? If they did, you know what to do, right? Who does not know that? Everybody does. I'm glad. So if they did say, give us a secondary alcohol, what were you supposed to do? You just make this CH2. Is that okay? And then you make this one CH3. That makes this carbon have 2 neighbors, 1 and 2. That means this alcohol is going to be secondary. Do you guys understand what I just did? So please know what to do. Take your time. It's very, very easy to make mistakes when it comes to organic chemistry, okay? And then you will be there like saying, I killed this exam. Where else the opposite? Okay, take your time. I used to have a mentality of saying, I'd rather not finish than writing something wrong. I'll get 90% because I answered 90% of the question paper. That means everything that I wrote was correct. You understand? Don't try to finish while you're writing wrong things. Question yourself, why am I writing wrong things? Because I know my stuff. Why would I do that? Is that okay? So I'm not saying don't finish, work towards finishing, but always worry about writing wrong things, okay? Because you know your story, you study. Look at you, people are on holiday right now, look at you, you're here. Next question. Now they say now, a tertiary alcohol that is structural isomer of the tertiary alcohol. What is butane 1-ol? It means now you have got butane, remember that? That has got an OH in one of the sides. Do you guys understand that? And then now they say now a structural isomer. That means a structural isomer are molecules that have got the same chemical formula, but they're different structurally. Is that okay? But then they're telling you now, give it to us as a tertiary one. That means the one carbon that has the OH there has got 4, how many carbon? 3, right? The tertiary alcohol means it's 3. Primary, secondary, tertiary. That's okay, alright, okay, let's do this nicely and slowly, as I was saying. Do it the way I want you to do it in the exam. Shh. So you will have CH3. I'm going to draw butanol first, guys. CH2, do you guys see that? CH2. And then, this is the OH, right? Do you guys see that this is the first one that they gave you? This one, yes or no? Now they want to structure an isomer of these by making sure that this alcohol is tertiary alcohol. That means the carbon that has to be attached to it must have 3 neighboring carbons. Yes or no? Yes. So how do we then do that? We say, let's draw a carbon here. Let's draw our OH because we want to. And then what it means is we must have those neighboring carbons. Is that okay? So that means here there must be a carbon, there must be a carbon, there must be a carbon. Do you guys understand that? So here what you're going to have is, you're going to have H, 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 H. This alcohol now has been made tertiary alcohol. That's what we want there. If you look into this, check this out. How many, let's draw the chemical formula for this thing. Shh. This is 1, 2, 3, 4. We have C4, right? Let's do the H's now. How many H's do you have there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Oh, is that okay? And then let's do this one. This one. 1, 2, 3, 4. C4. H is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Oh, it's the same thing. Or you could have said C4. H9, OH, it's the same thing. They won't punish you as long as you understand what is the difference between the primary, secondary, and tertiary. Are we fine? Don't rush yourself because you can do well if you don't rush yourself. Next question comes as follows. Okay. Learners, what are they saying there? Learners investigate factors that influence the boiling point of alkenes and alcohols. In the investigation, they determine the boiling point of the first 3 alkanes. Write down the investigative question for this investigation. Let me let you guys try this one. Learners investigate the factors that influence boiling point of alkanes and alcohols. Right? In one of the investigation, they determine the boiling point of the first 3 alkanes. Write down the question, the investigative question for this investigation. Don't you guys think you can say, does the increase in the chain length influence the boiling point? If you increase the chain length of an alkane, does that influence the boiling point? That could be an investigative question. What is the relationship between the chain length and the boiling point? That is the question. They said at school now it must have a what?
So it must answer the question yes or no.
Oh, it must answer the question yes or no. So let's say the question there is, what is the relationship between the chain length and the boiling point? So the investigative question that we'll say here is, what is the relationship between, I wrote 2 for you because I knew you were, between the chain length and the boiling point. Done. Fully explain explain why the boiling point increases from methane to propane. Methane has got one carbon. Remember one thing, guys. As you were saying, the investigative question, right, is what is the relationship between the chain length and the boiling point, because it's a question that does not have to have a what? A yes or no. The next question reads as follows. Fully explain why the boiling point increases from methane to propane. Methane has got only one carbon, propane has got how many? 3, right? Yes, sir.
So why do we specifically use chain length in the investigation question?
The chain is about the number of carbons. That is what we call a carbon chain. So if you increase the number, or we can say the number of carbons, if you increase the number of chain, the number of carbons in that thing, then the boiling point increases, yes or no? Yes, sir. I can't hear you. Yes, that.
So, sir, don't we consider the hydrogen bonds there, and because alkanes will only have London forces, right?
Yeah.
And then alcohol is going to have a hydrogen force.
That's
so
true.
Don't we consider that? Because then in our investigative question, we only consider the chain length.
We can't really consider what the hydrogens. You know why I'm saying that? The hydrogens are solely dependent on the carbon. That means the long chain influences what? The hydrogens that are there.
But sir, the alcohols will have hydrogen bonds which are stronger than that of the alkanes. Therefore, the intermolecular forces will be stronger than the alkanes. Therefore, the boiling point of the alcohols will be higher than that of the alkanes.
What do you guys say about that? Yes, ma'am? Your mic.
So we're dealing with one investigation which involves only alkanes, so alcohols are
Not on that. Yes. Thank you. Alright, so now, fully explain why the boiling increases from methane to propane. Methane has got how many carbons? 1. Propane has how many? So what would you say there? Let me give you a chance. You increase the chain length, right? When you increase the chain length, what happens? Looking into all your eyes, I see that you guys are stressed. Yes, there, those two there. What do you guys think? I haven't seen you today. Once you increase the, let's talk about this. Once you increase the chain length, you expect the boiling point to increase. Yes or no?
Yes, the thing is the chain increases, there's more chances of having London forces to be created because of the fact that now electron displacement, because there's more contacts on the more electron displacement, so there's more
intermolecular forces. Once you have more intermolecular forces, you need more energy to break those intermolecular forces. Hence the increase in what? In boiling point. Oh, well explained. Thank you. Did you guys get what he said? Oh, you want me to write it for you as well? Yes. And ask him to come and teach. Is that okay? So all you will then say, the increase in the length. This is now question number 1.3.2. 1.3.2. Then now you come back and say the chain length increases, chain length increases from one carbon, which is now what? The methane, right? You put it on black. You're showing them that I understand what I'm saying, what I'm doing. 2, 3 carbons in what? In propane. Obviously, you will know what to say here. Therefore, this increases the intermolecular forces. Is that okay? Is that okay? Once you increase the intermolecular forces, then what is it that you increase? You are increasing now what? the strength of the intermolecular forces. You can also say that the intermolecular forces increases what? The strength of intermolecular forces of I was also to say intermolecular forces there. Therefore, there is more energy that is needed to overcome the intermolecular forces. Hence, the increase in boiling point. And you've done it. Okay. The next question, I'm not going to take it out, guys. The next question reads as follows. Where is it? I'm going to let you guys try. Finish writing the stuff that I've been saying. Try to always apply yourself. The only one thing that makes people not to do well, even here at the university, people are always stressed. Okay? So the minute you stress out, you're blocking your thinking capacity. Is that okay? Be the most calm person ever when you're writing an exam. How do you acquire that confidence? By studying extremely hard. Is that okay? When you study, you must study. Like, I would advise that you even delete your social media. You guys can't do without TikTok. You can. It's only temporary. Is that okay? Shh. Guys, it's only temporary. You see with me when I was doing an undergraduate, literally over exams, I told my mother, like, listen, dear mother, I'm off WhatsApp, I'm off everything. We shall talk in 3 weeks. When I miss you, I will give you a call. And please do the same. Why? Because the other people don't really matter. Is that okay? What matters now is my life and what needs to be done. Is that okay? And look at you doing grade 12. This is your last chance of either being a doctor or a garden boy. I'm not joking. Or a maid. And look at you are here. Your parents are sacrificing so much for you to be here. Do the right thing and do yourself justice and study extremely hard. Do you understand what I'm saying? Do not lose this chance. This chance is very important for you guys, okay? Are you with me there? It's your last chance. Make sure you use it wisely. I'm serious by saying it's either you're going to be a garden boy or a maid or a doctor or a pilot. It's your last one. So why can't you give it all? I want you, even if you don't do it, and say, you know what? I'm at peace that I gave it all. Don't be like, I feel bad that I could have done better. No, no time for regrets. Is that okay? Do that. I advise strongly that you switch off the WhatsApp, okay? Delete it. And the TikToks. Shh. I'll tell you a quick story before I move on to the next question. The other day, I went to the study center in the library at the university. Literally, I was sitting next to some other students, and I was looking into the study pattern. People really have a low concentration at times. They do one question, they take their phone. One question, take their phone. Is that okay? And then I'm questioning the legitimacy of the study. You know what I'm saying? And everyone was doing the very same thing. If you feel like you don't want to delete the WhatsApp, it's also fine. But shh, discipline yourself in a way that you time yourself, like for the next 1 hour, I'm not touching my phone. I'm doing this. Is that okay? You take your phone, you watch videos, you go back. Do you understand what I'm saying? There's a catch to it though. The way social media is designed for you to stay. Is that okay? I was a person that used to watch series in between my studies. I will watch one episode, I swear to you, the next episode you want to see it. You will then not study because now what's happening? This thing is so awesome. So I don't know, do what's best for you, but I want to see all of you here next year. Okay? Please. Alright, next question. The learner found that the boiling point of propanol is higher than that of propane. Is that okay? That's where his question comes through. Yes, sir. That's now where your question comes through. Where you're comparing what now? Propane and the propanol. Is that okay? The propane has got the London forces only because it's what? Non-polar. Are you agreeing with me? But the propanol now has got what we call hydrogen bonding. It is polar also. Do you guys understand that? So I think you can be able to explain this question. So now they say now, explain the observations relating to the type of intermolecular forces present in each of the following compounds. First of all, we can say propane is non-polar, right? Propanol is polar. Do you guys understand that? The other one has got what? London forces because it is possessed by a non-polar compound. I'm not going to write this way, I'm just going to speak it through. Okay. So 1.4, you say now, between propane and propane, there are London forces because the molecule is not polar. Is that okay? Non-polar molecules. But between the propanol or the one prop-all molecules, there is dipole forces because this molecule is a polar molecule. And then once you've got a dipole, you also have what you call hydrogen bonding. Is that okay? Because of the oxygen and the other hydrogen. Is that okay? And then also, you have there is a little bit of London forces on that side that doesn't have the OH. The O, do you guys see that? There is. So there's three. There's London, there's hydrogen, and then there's what? Dipole, because it's a polar molecule. Why are we saying it's polar? Even before you draw it, it has a lone pair on that oxygen. Do you guys see that? Sure. Then you're good to go. You get all the 3 marks there, and then you move on. Let's attempt question number 2 so that we can move on. Would you guys want to do this one? No. You know why? Already before you read the question, you can see that this one has got a higher boiling point. Do you guys see that? Yes or no? You can already see that the thing has a higher boiling point. You investigate, you know how to write the question. You must not have blah, blah, blah. There's an independent value, there's a dependent value. Is that okay? Why the other one has got a higher vapor pressure? It's the same concept using the intermolecular forces because vaporization means you're changing something to become a vapor. Is that okay? So if you've got higher intermolecular forces, you can't vaporize it as quicker as the one that doesn't have. Is that okay? It's simple like that. So with this question, I think you will get it on the memorandum. You'll be able to answer this question with all the knowledge that you acquired on the first question. It's not so long, it's not so hard, it's very doable. Okay. The next question that I want us to look into are the naming of compounds in organic chemistry. That's the one thing that I'm actually rushing to. Okay. Page 12. Do you guys want to attempt doing this? Wow. Before you even do that, can I request that you draw me this structure quickly? Draw it for me on your book. That structure 2,2,4 trimethyl or methyl hexane. That means the long chain is having how many carbons? At carbon number 2, there's how many methyls? There's 2 methyls in carbon number 2. Do you guys all see that according to the thing, right? And then also there's also a methyl at carbon number what? Draw it for me then. I'm asking you nicely, sir. Because I know you can. Draw for me the one in A. So the one that is found in number A, it means there are how many carbons? You start with the long chain because hexane means 6, heptane means 7. Do you guys remember that octa means 8, none or nano means 9, deca means 10. So all you then do there is like, all right, let me have all my 6 carbon. You say it's carbon, 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 carbon. 1, 2, 3, 4, 5. Then you draw the 6th one on this side. Okay. At carbon number 1, there is CH3. And then here, there is a methyl group. Do you guys see that? We can say this is always number your carbon and say this is number 1, number 2, number 3, number 4, number 5, number 6. So that you avoid making mistakes, I want you guys to learn to do things slow and then you put H dash, you put HC there, you put H, you put H, you put H. That's why we're saying dimethyl. If they say diethyl, that means this group has 2 carbons coming out from this, right? Diethyl. So we say 2,2. It means there are 2 methyl groups in carbon number 2. Do you guys understand that? And then now, carbon number 3, there's nothing. There's an H, and then there's an H. Carbon number 4, there is a methyl group. Do you guys see that? When you get to the university, you will learn other nicer things to do. Alright, and then you do this, and then there's nothing in carbon number 5, there's nothing in carbon number 6. I just want you guys to learn how to do this, okay? Please, this is the structure that you need to form in carbon number as number 1 there. Okay, so now we can try and attempt. And then do you guys want to do number F? Yes. Please attempt drawing number F for me. 1 means ketone. Do you guys understand that? If we say 2, 1, it means at position number 2, there's a ketone. Is that okay? You will never in your lifetime and get 2 anal. I don't know if I just confused you. Anal is what?
Alcohol.
Because why? There is always carbon number. It's always at the end, so it's always carbon number. You can never get 3 butanoic acid. You can never have the butanoic acid inside the chain. It's always carbon number 1. It's always number 1 because it's at the end. I don't know if I just confused you. Did I? So please make sure that you remember that aldehyde is one in between 2 things. Pentanal, meaning number, carbon number, how many carbons here? 5. Let's do it. You have 1, C, 2, 3, 4, 5. Is that okay? And then you have this, and then you have that. Don't forget that carbon is a tetravalent. That means here, look at this, you can never have an H down here. Do you guys understand that? It's a common mistake. There's no H that you will put here. Agree with me? Because this carbon is already have 1, 2, 3, 4. Okay, so all you then continue doing here, you put an H there, you put an H there, you put an H there, you put an H there. Then you come back, you say H, H, H. That means you are very done. Okay? It's not bad. Now let's start answering the question. Write down the letter that represents the following: an aldehyde. So you need to look for an aldehyde functional group. An aldehyde, I did tell you that you can either see it by having CHO or C double bond this or that. Do you guys see that? So all those 3, 4, 5 to F structures, look into the one that has that condition. Which one is it? Are you guys going to struggle? No. So the answer there is what? B. A condensation polymer. Which one is a condensation polymer, guys, there? Basically, they're asking you what forms that, I don't know if you guys can see something there. Do you guys see that this is an ester? Do you guys see that is an ester? How do you get, or what is esterification? Is when you react to what? A carboxylic acid plus what? Let's just repeat that. I want to tell you guys something. This side is the alcohol side of things. Do you guys understand that? This side is the carboxylic side of things. A condensation polymer is when there was water that was what? What is that? Talk to me. You didn't do that? No, you haven't done polymers as well? Okay, I'll give the answer for this one. Shh. So if you can use water to break this thing, it will make it a condensation polymer, basically. Is that okay? If you introduce water, it was formed by dehydration, because water was thinning. If you introduce water, it will split up to become what? The carboxylic acid and the what? And the alcohol. It's called esterification. But if you split those two things, we call it a saponification reaction. I don't want you to think about that word. In your mind, it doesn't exist, okay? But it does exist in chemistry. So the condensation reaction there, which one did I say? It's what? It's E, okay? A compound which has got a carbonyl group bonded to 2 carbon atoms as its functional groups. Come on, guys. It's F. Do you guys all see that? A carbonyl group that is bonded to 2 carbons as its functional group. And we did draw this structure. Do you guys remember that? You can see it's a what? A ketone. A ketone is found in between 2 carbons. Alright? So we say, what is the answer for this one, guys? It's F. Give the IUPAC name of number C. I'm going to let you guys attempt doing this one. How do you give an IUPAC name? First of all, find the longest what? Chain. Let me let you guys try it. How do you find the longest chain here in number C? You need to count the number of carbons first. That is the rule. Find the longest chain. And then once you find the longest chain, you need to choose which one has the lowest numbering in terms of branching out. So what I was saying here is, guys, you need, because here we're looking at compound number C, the rules of IUPAC, find the longest chain. Once you establish that this is my longest chain, you need to look for where do you get the first substituent out in terms of numbering. Is that okay? So if you look at this one, you can see that the longest chain is 1, 2, 3, 4, 5. Or you can say 1, 2, 3, 4, 5. Do you guys see that this is the same thing? I don't know if you are with me. I say to you, this is 1, 2, 3, 4, 5. The linear structure, the one that is just like that. Or you could say 1, 2, 3, 4, 5. You can even say 1, 2, 3, 4, 5. It doesn't matter. Why am I saying it doesn't matter? If you decide to go like this methyl is a substituent. Do you guys see that? If you go like this methyl is still a substituent at carbon number what? 2. If you count from this side. Do you understand? So now, but let's look at it now. Which one has got the lowest number? And do you see that if I say 1, 2, there's bromine. If I say 1, 2, there's methyl. This is when now you consider alphabetical order. Which one comes first between bromine and methyl according to A, B, C to Z? So that means the structure here is number 1, number 2, number 3, number 4, number 5. You could even come to number 5 that side. So the fact that it has got 5, what does it make? It makes it a butane, right? Yes, it makes it a butane, yes? Thank you. I was just tricking you to see if you have to hear. It's a pentane. Do you guys all understand that? So we write the name of the parent chain on the side because I feel like if you don't do that, you might be wrong, okay? Let's write the name of the parent chain on the side of number C. We said it's what? Pentane, right? So now let's look into how is it connected to people. At number 2, there's a what? At number 2, there's a what? A bromo. We don't say there's a bromine. We say bromo. Is that okay? If it's chlorine, we say chloro. Is that okay? If it's iodine, we say iodo. Do you guys understand? And then at number 3, what do we have? We have a chloro, right? And then we say number 3, you have a what? A chloro. And then number 4, there's a methyl, yes or no? The most important thing to people, the letter, this letter, and this number and this letter is separated by this. Do you guys remember that? But then now let's connect it now, because we're actually done. Do you guys see that? Which one comes first between B, C, and M? So now let's come up with the whole name. So we have everything that comes up there. We're going to come and say our full name for this structure is equals to 2 bromo, okay? And then a letter and an alphabet is separated by that. Do you guys remember that? And then what comes now after that? Is it the chloro or the methyl? And then you say now, how much is it? 3 what? chloro, and then the methyl is position number how many? And then you come back and say this is 4-methyl pentane. Do you guys understand that? I'm supposed to write it small, but no. And this is the name that they're looking for. It's not bad, right? Please use your IUPAC rules wisely. It is very, very important that you remember them. The next question reads as follows. So we are done with this one. The monomer of compound D. What is a monomer of compound D? Monomers, disaccharides. Mono means one. Di means two. Yes, sir? You guys don't do the polymers? Alright. Let me just scratch them out. Okay. You guys don't do polymers, yes or no? Shh, not doing polymers. It never happened in this case, okay? Forget it. So let's forget about that. Now write down the structural formula of compound A. Didn't you draw this? Didn't you draw it? The structural, they said write down the structural, the structure, how it looks like. Oh, I was doing you guys, and we even drew F. Do you guys see that? This F, where are they in my? I want to really find them for someone who was sleeping. This one we said is what? It's A. Do you guys remember that? Yes or no? And then F, we said there's a ketone. Where are you, F? Come back. Yeah, but F, we said it looks like. No, let me try and do better. I'll say this because I feel like it's too filled now. There should be 5, right? 2, 3, 4, 5. And then the structure has to look like that. So now we're saying this is 1, this is 2. This 2 like that. This is like that. This is like that. This is like that. This is like that. Guys, it's not so bad. You just need to try and apply your mind and apply yourself to it, and then you'll be good to go, okay? And then now they say the table contains compounds of functional isomer. Define what is a functional isomer. What is a functional isomer of an aldehyde? Thank you for saying that. So, what is a functional isomer for people? So, these are compounds that have got the same molecular formula but different functional groups. For example, aldehydes and ketones. Do you guys understand that? Please, please, please. You can always think about it like that. Functional groups are different, but chemical formula is there. So now they say here in this question, the table contains compounds which has functional isomers. Define the term functional. It is a compound that has got the same molecular formula but different functional groups. You do have that answer, right? And then the next question says, write down the letters that represent the two compounds that are functional isomers. The one that contains functional isomers, remember I said it's ketones and what? Guys, please don't embarrass me there in that test. I said it's ketones and what? So, are you going to be wrong by saying B and F here?
No, you'll be wrong.
Please, guys. Please, 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 you need to know your story. Alright. It's not going to be a very bad thing. All you need to know is to try and apply yourself. The last one, this one, they say name the functional group in number B. Do you guys see the spec that it ends with oic acid? Do you guys see that? Yes or no? That means it's a carboxylic acid. Do you guys mind drawing it for me? If you can draw me this and this, I'm glad I will let you go. Draw it for me. I'll be very glad and I'll let you go. So with organic chemistry, guys, you know what's nice about it? it doesn't change. Do you guys understand? It's either you know what you are doing or you do not know. If it's an addition reaction, what happens? If it's an elimination reaction, what happens? It will never change. So that when you come here next year, with all the organic chemistry modules that you will do here, you must get distinctions because it's either like that or it doesn't happen. Is that okay? There's no logic to organic chemistry. Either you know or you do not know. Are we with me, guys? So now let's try. I said, please draw for me number B and F. And E, sorry, my bad. Draw it for me, and then you'll be good. Nothing in this world is hard. Tell yourself that mentality. Okay? What matters is the time input that you put to the work. Do you understand? The word hard doesn't exist from today onwards in your vocabulary, okay? It's about the input. You can't expect results of something that you didn't work for. Is that okay? Just like if you want to look very muscular, you think you will just chill in the couch and you just become buff. You need to go to the gym and work out, okay? So you work out for something, you work towards what you need. So you can't just get results of something that you didn't do. You can't get 9 distinctions if you're not studying hard. I know you will, right? The day you pass with 9 distinctions, tell them that Sydney said I can. Okay? Because I know you are capable. No one is not capable in this world. Okay? So now let's do number 2B. I said, how do you do B? It's butte. Remember I said butte. Butte means how many? 4. And I said the acid is always carbon number 1. If it's a carboxylic acid, it's always number 1. Oh, it's an aldehyde. So now let's do it as a carboxylic acid. So let's just drop 4 carbons. 1, 2, 3, 4. Number 1, which I can just put this side, looks like that. Do you guys see that? And then now, number 2, because this, obviously, this is going to cover number 1. Carbon number 2, there is a methyl. Do you guys see that? So there's a methyl, it means there's a CH3 there. Shh, guys, please. That means here there's an H, that means this is CH2. And then that means this is CH3. Shh. So that's how you get number B. Easy, right? And then now let's look into how do you do number 4, number E, sorry. Number E reads as follows. Butte 2-in. That means there's a double bond in carbon number 1. And how many carbons do we have? 4. So all you do is you draw 4 carbons, say 1, 2, 3, 4. And then if there's a double bond here, there's only one H and only one H, because I remember I mentioned to you that H is straight what? Violent, means it has to have 4 bonds. You guys can see? Can I just use a different pen? Is that what you're saying? Yeah, the double bond is in the wrong place. It's carbon number? Yes, okay, well, my bad. Thank you so much for that. So you say C, 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 C. And then you say carbon number 1 and 2. 1, 2, 3, 4. I was going to figure it out when I was explaining something. What I wanted to say is, if they say 2-in, it means the double bond is in carbon number 2, between carbon number 2 and the next one, which is number 3. So we put the double bond where, guys? Here. And then here we say H, H, H. Is that okay? And then here we introduce only one H. We introduce only one H. Don't forget, as I was saying, carbon is trivalent, meaning it has to have 4 bonds. Hence, I'm saying this one is good. 1, 2, 3, 4. 1, 2, 3, 4. Immediately you put an H there, you are extremely wrong. Do you understand that? Because carbon cannot have how many? Okay? Guys, good luck, and I have loved the time that I was given today. Good luck with everything.